All right, hello again, now for two people. So this is the second, or I guess third video in the series of factoring. The previous video just went through two examples of factoring when A is not one. Today's video is going to just go through a couple more examples of how to factor a quadratic and solve a quadratic when A is not equal to 1 using what some people call the swing method, and kind of go from there. I'm also going to talk about a couple special cases at the end of the video. So here's example 3 is the next one we're going to do. So again, what's the process? So if you remember, you've already done this before. If you see at the top there, kind of in that red box, those are these steps. If you need to kind of pause the video, take a screenshot, you can do that. But this is the process that you need to have kind of ingrained in your head so that you can do these successfully each and every time. So first thing, check to make sure the quadratic is equal to 0. That has to be, it's got to be everything on one side first. So if you see this one, we need to subtract the 6x from both sides. So if I do that, my quadratic now becomes 2x squared minus 11x plus 12 equals 0. And now we can begin the process. Okay, once it's equal to 0, now we can start the factoring thing. Okay, so what's the first step? We've got to multiply the a times the c. So a times c, 2 times 12 is 24. So it's going to be x squared minus 11x plus 24 equals 0. And now we should be able to factor that almost in our sleep. So what multiplies 24 adds to be negative 11. Be negative 8 and negative 3. Obviously, the order doesn't matter. And then we have to, the next step, we have to undo our cheating. When we multiplied that 12 times 2, we were kind of cheating, right? So we can come back and redivide by that a value, by whatever I multiplied by, redivide by a. If you can simplify it, great. 8 over 2 is 4, so that just becomes x minus 4 for the first factor. The second one can't be simplified. And what happens then, if it can't be simplified, then we're going to take whatever the denominator is, and we're going to move it in front. Okay, so my final factored form is going to be that. X minus 4 times 2x minus 3. And remember, you can always check that. You can do, you can multiply that out, FOIL, box method, whatever makes you happy, and you'll get your original equation. Okay. Now for the solutions, remember all we do from there is just set each factor equal to 0 and solve. So if I add 4 to both sides, my first solution is x equals 4. Same thing with the other one. The other one, though, involves 2 steps. So I got to add 3 to both sides. And then I've also got to divide by 2. So x equals 3 over 2. So those are your solutions, roots, zeros, x-intercepts, whatever you want to think about that. Okay. So I'm going to ask you now to go ahead and pause the video, do example 4 by yourself, and then I'm going to go ahead and zip through the process and the answer real fast. Okay, so it's already equal to 0. Don't have to worry about that. So I'm going to multiply the a times the c and rewrite as x squared plus 13x minus 30 equals 0. Be careful on your factors on this one. What multiplies to negative 30 and adds to be positive 13? That'll be positive 15 and negative 2. It's awfully easy on this one to have your factors at 10 and 3, but that does not work for what you have to have it equal to. Okay, then we got to go back in and divide. So divide both of them by 10. Simplify I'll write this over here. So 15 over 10 is 3 over 2. 2 over 10 is 1 over 5. And then when we swing, this time we have a denominator in both of them, but that's okay. So my final factored form is going to be 2x plus 3, and then 5x minus 1. And again, FOIL box method, you can multiply that out and get what you started with. For the solutions, 2x plus 3 equals 0. Subtract 3, divide by 2, so you have x equals negative 3 over 2. Same thing on this one, 5x minus 1 equals 0. So x equals 1/5. Add 1, divide by 5. I got one last example before we start talking about some special cases. Again, if you want to pause the video and do this one, but do keep in mind, always, always, always look to see if there's a GCF that you can take out, factor out, and make the number smaller. So go and pause the video one more time, and then we'll go through this solution. Okay, so notice in this case, all of my coefficients are even. I got 6, negative 20, and negative 16. So I can take a GCF of 2 and bring that out front. And you should always do that if you can, because for heaven's sakes, why not make the number smaller? So we have that, divide everything by 2. Now that 2, that GCF, is just gonna hang out of it. Don't forget about it. It's still part of the equation and still part of the factored form. So now we can just work on what's inside. So we take 3 times negative 8, which is negative 24. So we rewrite it. What multiplies negative 24 adds to be negative 10. And again, be careful because it's easy to say 6 and 4. But we don't want that because of how it has to multiply to a negative 24 and add to be negative 10. My factors are negative 12 and positive 2. I'm going to come over here. So 2x minus 12. And x plus 2. Now we can divide by my a, and again, whatever I multiply by the inside there, which is 3 in this case, simplify it. So this is just x minus 4. And this is, I can't simplify that one. So whatever's left over, we swing in front of that x. So my factored form is going to be 2 times x minus 4 times 3x plus 2. And then for your solutions, we're doing the same thing each time. So that equals 0 and solve, so x equals positive 4. 3x plus 2 equals 0. Subtract 2, divide by 3. X equals negative 2/3. Okay? It does take practice. If you go to Google and you put in factoring quadratics, you're going to find about a gazillion practice worksheets and practice problems and videos and all stuff like that. So if you need more practice, I really encourage you to do that. All right, last thing to wrap up this video, we're going to talk about a couple special cases. So take a look at the next example here. We got x squared minus 25 equals 0. Notice there's no b value. There's no x. So in this case, my b is actually 0. I could, if you wanted to, I wouldn't do this most of the time, but if you want to write this out just kind of visually, it's kind of that, right? So Now you just factor it the same way you're used to. So how can we multiply to negative 25 and so add to be 0? That would be 5 and negative 5. So we can factor that as x minus 5 and x plus 5. And my solutions, same thing. So say each one equal to 0 and solve it. So x equals 5, x equals negative 5. Now, this special case, if there's no b, if there's no x term, this has a name. It's called the difference of squares. Why is it called the difference of squares? Because both terms are there. The x squared is a perfect square, and the 25 is a perfect square, right? And it's a difference because you're subtracting them. Okay, so anytime you see the difference of squares, you can factor it just with that plus minus technique. Okay? Even something like number 7. Number 7 doesn't have a b value either, but remember, look for a GCF. I can divide both of these things by 3, so if I take a 3 out, now my inside is a difference of squares, x squared minus 4. So I can get to negative 4 by doing 2 times negative 2, which has to be 0. So my factored form, the 3, again, the GCF just hangs out. So negative 2 and positive 2 is my factored form. And my solutions, 2 and negative 2. You could also write that, if you want to do like a little shorthand, you could do x equals plus or minus 2, and that's okay too. Okay, now, last 2 things I want to talk about. Look at example 8 and look at the difference and how example 8 is not the same thing as example 6 and 7. Notice now there's still no b value, but now it is a sum. This cannot be factored because in order to get positive 36, we'd have to either have to do x plus 6 and plus 6, or I guess we do 9 and 4 or 1 and 36. But if they're all positive, that doesn't add up to be 0 for the middle term. If they're all negative, it still doesn't add up to be 0 in the middle term. So this is not factorable. Okay, now there are still solutions. That's going to come later. We're not going to talk about that right now. But for right now, there's no real solutions because it is not factorable. This also has a name. I'm going to put it in red because it's not factorable. This is the sum of squares. Which is not factorable. Okay, so we have x squared minus a number, factor it, plus minus, just like example 6 and 7. X squared plus a number, not factorable, and we move on. Same thing on number 9, really. It's not, number 9 is not really a special case, but I want to show you what happens. Notice there's nothing I can do here because if I'm trying to get to negative 6, I can either multiply 1 and negative 6, or negative 1 and positive 6, or I can do 2, negative 3, or negative 2 and positive 3, right? None of those combinations, though, will add to be positive 7, so this is also not factorable. Now, I'm not going to try to trick you on any assignments or tests for right now. I'm not going to give you one like this, but I want you to see that not all quadratics are factorable. There is going to be a technique that we're going to learn later on about how we can still find the solutions without factoring, but we'll get to that later on. Okay? The main part of this video today is know those special cases of the difference of squares and know how to factor a quadratic with a leading coefficient. Okay, if you have questions, please let me know. Come to tutoring, talk to your teacher. Until next time, stay safe.